Hi, this video is a sequel to the previous videos showing the animations of rotary motion, and here we are only going to look at the main equations. The velocity consists of the linear velocity and the angular velocity. The linear tangential velocity of a rotating disk or body is expressed as v, and that's equal to r into omega, where r is the radius of action. At the edge of the disk, you would take the full radius of the disk. In the center of the disk, you would take half the radius of the disk. The angular velocity omega is the way the angular displacement changes with time. So that's d by dt of theta, where theta is the radians. The angular acceleration alpha is the way angular velocity changes with time. So that's d by dt of omega, and also written as d squared theta by dt squared. The displacement is like what we had in the linear motion. We had s equal to ut plus half at squared. Here you substitute the values for angular motion and you get theta instead of s, and instead of ut you put omega I into t, where omega I is the initial angular velocity. Instead of a you put alpha, and you have the equation that you see on the screen. So remember the linear equations and substitute them with the correct things for the angular equation. The other two equations are also an extension of what we saw in linear motion. We had v is equal to u plus at. Here you have omega is equal to omega I plus alpha into t. That's easy to remember. We had an equation for linear motion, v squared minus u squared equal to 2as. Here we will get omega squared minus omega I whole squared equal to 2 alpha into theta, because we substituted a and s by alpha and theta. I hope this was clear. Thanks and have a great day.